Okay, and welcome to the introduction of vector addition. So vector addition, first what we need to know is what vectors are. Vectors, if you don't remember, are basically a magnitude with a direction. So things like velocity, force, displacement, all of that is a magnitude. It's going to be an amount, right, with a direction applied to it. Now, this can be easily represented with certain arrows. So you might think of something like this is a vector, okay? And let's say this vector is 10 meters per second. So it is a velocity vector. Now, if you have just one of them, that's fine. It's pointing to the right. We have a magnitude, so we have a magnitude, we have a direction, right? The arrow is just to represent it, and it is a velocity. But we need to get to vector addition, which means we need to have at least more than one. So let's take a look if we had another one. So let's say we had another vector, and this one's only worth, let's say 7 meters per second. But this one is to the left. Now, we'll talk in a minute what that really means, and a way to represent it without showing the actual arrow would be to say, okay, then this is a negative 7 meters per second. But for right now, we're just going to show it as an arrow, and we can see that it's going to the left. Vector addition is basically adding both of them together, and we do that by putting them tip of one to the tail of another, and then you go from the tip of the original, or the tail of the original, to the tip of the last one. Let me show you what I mean. So let me take this one, and I'm going to put its very tail end on the very tip of this one. Let's just set it, we'll set it below it for right now so you can see it a little bit better. But you can see that if we started here, first we had a velocity going this way, and then we had a velocity going that way, right? Well, that's going to create what we call a resultant vector. So if we add those two together, we'll use a green plus sign. I'm adding these two vectors together. Because that 7 is really a negative because it's in the left direction, it's going to create a shorter vector. That shorter vector we would call the resultant. Let's see if I can grab a hold of this one. So this is my resultant. So notice that that's really just what's left out of the distance there, because that one was longer. So we could say that this is the resultant vector, and it would be worth only what those two are added together. So I'm going to go back and I'm going to call this vector A, and I'm going to call this one is vector B. And so that's going to give us a resultant vector, and that resultant vector is going to be equal the 10 meters per second plus the negative 7 meters per second. So that's going to give us 3 in the positive direction meters per second. And it works just like that. And you can actually see this stacking them on top of each other. So let's do that. There's our red one. If we put it tip to tail, I would try to set this right over top of it. There it is, tip to tail. And that would give us a resultant of that one right there. See how they end up perfectly aligning? So it makes basically what would almost look theoretically like a complete circle or complete line. So if that first one went all the way to there, then that one cut back there, our resultant is just the amount left over. That's the whole premise behind vector addition. There's just one more part we need to understand. See, the problem with vectors is a lot of this was created on graphs. And so with graphs, you have a y-axis and you have an x-axis, right? And we can determine what their values are going to be based on which way they're going. So if I have an arrow that's going this way, we can see that that one's very obviously going to be a positive in the x direction. Now, if we had another one that was going this way to the left, it's going to be negative. In the x direction, right? So that's why, by convention, if it goes to the left, it's negative. If it's to the right, it's positive. In the same way, if it goes up, that's considered positive in the y. And so we would write that as positive in the y. Or if it goes down, you can see that it's actually negative. I don't know why I made that G a Y. Negative in the y direction. And that's where the convention comes from, that up and to the right are positive, down and to the left are negative. We just apply this graph scenario to real life, okay? Now you need to understand that they have to be on the same axis to add them together. So you can't put something from the positive y added, or positive y added to the positive x. You can only do x to x and y to y. So remember that it has to be on the same axis in order to actually do the vector addition. And that is the most basics of vector addition.